So today's lesson was on graphing linear inequalities, and it is a part of our Systems of Linear Inequalities unit. This is the warm-up that students started off the class with. Go ahead and pause the video and try the warm-up on your own. Number 1 asked you to graph the equation x equals -2. When you see an equation in one variable, and it is of the form x equals some number, you should think that the graph is going to be a vertical line that goes through that number. So in this case, the graph of x equals -2 is a vertical line that goes to the point -2, 0. Notice how this line goes through every point on the graph whose x-coordinate is -2. Number 2 says to circle all the points that are solutions to the inequality x less than -2. So here we're looking for any point whose x-coordinate is less than -2. You should have circled -3, 4, -6, 4, and -8, 1. That's -3, -4, sorry. Number 3 says to graph y equals x plus 5 on the same set of axes as number 1. To do so, we first need to recognize the slope and the y-intercept of this line. Since this equation is in slope-intercept form, we can see that the coefficient of x is 1, which means the slope is 1. We also see that the constant being added to the equation is 5, which means the y-intercept is positive 5. So graphing this equation, you should get something that looks like this. Number 4 asks you to circle all points that are solutions to the inequality y greater than x plus 5. So here we are looking for any point whose y-coordinate is greater than 5 more than its x-coordinate. If we look at the first point, -2, 0, we can see that this is not a solution, since -2 plus 5 equals 3, and the y-coordinate, which is 0, is not greater than 3. If you do that for each of the other points, you'll find that -3, 4, -6, 4, -7, 3, and -8, 2 are solutions. Number 5 says, graphically, what is similar about each of the points you circled in number 4? Let's look at these points on the graph to see if we can find any similarities. In class, some students said all of the points are in quadrant 2, which is a good observation. They also said that the points are above the line y equals x plus 5, which is what we are going to be focusing on for the rest of the lesson. Now we're going to look at some graphs on Desmos to show you how we actually graph these inequalities. First, we have the graph of y equals x, which is a line with a slope of 1 going through the origin. If we select y less than x, we see that the dotted line is the same as the graph of y equals x. Now the lower half of the grid is shaded in red, since this space represents all points whose y-coordinate is less than their x-coordinate. Therefore, this represents the inequality y less than x. We have what is called the boundary line of this inequality as a dashed line, since all points on this line have y-coordinates that are equal to their x-coordinate, and therefore do not satisfy the inequality y less than x. So points on this line are not solutions. However, if we select y less than or equal to x, we see that the dashed line has turned into a solid line, since the points on the line are solutions to y less than or equal to x. Now if we look at the graph y greater than x, we can see that we have a dashed line again, since y cannot equal x in this inequality. What's different now is that the upper half of the grid is shaded, since the region represents all points whose y-coordinate is greater than their x-coordinate. Lastly, we'll look at y greater than or equal to x. We see that the only difference here is that we have a solid boundary line, since the points on this line are solutions to y greater than or equal to x. Now going back to the slides, students had completed these questions for classwork. They did it with a partner. Pause the video and try to do the questions by yourself. So number 1 said to graph the inequality x plus y greater than or equal to 8. In standard form, this is y greater than or equal to negative x plus 8. This is because you subtract x from both sides of the inequality. We can see it has a slope of negative 1 and a y-intercept of 8. So we have the boundary line at y equals negative x plus 8. This line is solid because our inequality includes the equality. And we shade above the line since the inequality is greater than negative x plus 8. 2. Circle all points that are solutions to x plus y greater than or equal to 8. So we're looking for points whose sum of their x-coordinate and y-coordinate is greater than or equal to 8. These points are 8, 0, 7, 2, and 2, 7. Three says to graph a new inequality, y less than 2x plus 1, on the same set of axes as number 1. So that's what your graph should look like. Four, which of the points you circled in number 2 are also solutions to y less than 2x plus 1? The 3 points you circled in number 2 are shown on the graph. We can see that 7, 2 and 8, 0 are solutions because they're in the shaded region of y less than 2x plus 1, and 2, 7 is not. Number 5, graphically, what can you say about these 2 points in relation to both x plus y greater than or equal to 8 and y less than 2x plus 1? We can see that they are in the shaded region of both inequalities. Number 6 says, when considering a system of inequalities, how can you identify the solution set by looking at the graph? To answer that question, we'll give a definition of a solution set. The solution set of a system of inequalities is all points in the shaded region created by the overlap of shaded regions of all of the inequalities. In this graph, the solution set is the darkest shaded region. This represents the overlap of the 2 solution sets of these inequalities. After students completed the classwork, they also did a Desmos activity. Log on to Desmos and enter this class code to access the activity. So let's do challenge number 1 together. So in row 4, we want to write a linear inequality that meets these 2 requirements. So the boundary line has to be y equals 1/2 x plus 3. And the blue points must be solutions. Well, let's put in the boundary line and see where that puts us. So we see that one of the solutions is on the boundary line, and another one is above it. So we can just change what we wrote here so that the 2 blue points are solutions. If we make the inequality y greater than 1/2 x plus 3, we get that the point 0, 5 is a solution. However, the other blue point is on the dashed line, and it's not a solution. So we'll have to change the inequality to be greater than or equal to. And now both blue points are solutions. Go ahead and try the rest of the activity on your own. So if we do challenge number 2, we want an equation that satisfies these conditions, an inequality actually. So we want the boundary line that is vertical, we want the boundary line to intersect the point 2, 5, which is given in black here, and we want the blue points to be solutions. Well, if we want the boundary line to be vertical and intersect 2, 5, we know that the line x equals 2 is vertical and goes through the point 2, 5. However, we want it to be an inequality, and we want the blue points to be solutions. So just as we did before, we can see that one of the blue points, the point on the origin, is to the left of the line x equals 2. So we want our inequality to be x less than 2. However, the point on the line isn't a solution in that case, so we have to make it less than or equal to. For challenge number 3, we have to write a linear inequality that meets the requirements of a boundary line whose slope is negative 2 over 5, a boundary line whose y-intercept is negative 2, and the blue points are solutions. Well, using y equals mx plus b, we are given a slope and a y-intercept, so let's write the equation of a line with a slope negative 2, 5 over 5, and that y-intercept. So we have negative 2 over 5x minus 2. Now we want the blue points to be solutions, right? Well, one of the points goes through the line, so we know it either has to be greater than or equal to or less than or equal to. And the other blue point is below the line, so it looks like it's going to be less than or equal to. Let's see. Yep, both blue points are solutions. Going to challenge number 4, we have to write an inequality that meets these requirements. The boundary line is horizontal, which means it's going to be y equals some number. We want a boundary line that intersects the blue point, 0, 8. We need that point to be a solution, and we do not want the red point to be a solution. Well, we need the boundary line to be horizontal and intersect 0, 8. So that seems like we'll have a line x equals 8 as the boundary line. We need the blue point to be a solution, so it'll be less than or equal to or greater than or equal to. And we do not want the red point to be a solution. The red point is below the horizontal line, so we need to have y greater than or equal to 8. And there we go. For challenge number 5, we need to write a system of inequalities that satisfies the following. The blue points, there's 3 of them, are solutions. Well, we could think of 2 easy ways to do this. We could do a vertical line and a horizontal line. What I immediately think of is just do some vertical line to the right of all these points, and then the horizontal line can either be above or below, and we can tailor the inequality so that the blue points are solutions. Let's have x is less than 5, and then maybe y less than 10. And all the blue points are in the overlapping shaded region of these 2 inequalities. Now, if we wanted to make it a bit harder, we could have lines intersecting these points and make inequalities out of those. So if we want to find the slope of a line that would intersect this point and this point, we'll do rise over run. So 1, 2, 3, and then we're going to the left, so it's going to be negative 1, 2, 3, 4, 5, 6. So 3 over negative 6 is negative 1/2 x, and we can see that the line will go through positive 5. So we have y equals negative 1/2 x plus 5. Okay. Now we want it to be an inequality, and we want it to include this blue point. So we'll have to make it less than or equal to. Great. Now we want another line that can go through these points. So we'll find the slope here. That's 1, 2, 1, 2, 3, 4. But it's supposed to be rise over run, right? So maybe 1, 2, 3, 4, 1, 2. So we went down, that's negative, and then left, that's also negative. So it's a positive slope. It's actually a slope of 2. 4 over 2 is 2. So we want y equals 2x, and it goes through the origin. So we have a 0 y-intercept. Now we need to make this an inequality, and we want to include this blue point over here. So we need to be above the line. So greater than or equal to. And that includes the points on the line and the third blue point. There we go. Finally, for number 6, we want to write a system of inequalities that satisfies the following. The blue point is solution, and the red points are not solutions. So this is a pretty small margin where we have to get the blue point in, and the red point's not. Well, I would do 2 parallel lines that just are very close to each other. They include the blue point and not the red, going like this. So we can find the slope of some line that might go through here. Let's see. Say the line goes through positive 5 right here. And it goes to this point also. So that slope would be 1, 2, and then negative 1, 2. So negative 1 slope. And a y-intercept of 5. Okay, so it goes through that point. And maybe one point below it, maybe one that goes through positive 4, and we want them to be parallel, so we want them to have the same slope, so we'll have y equals negative x plus 4. So we just want this little area between them to be a solution set, so it doesn't include the red points. Therefore, we can make this less than or equal to. And this one can be greater than or equal to. It doesn't matter because it doesn't have a solution that needs to be on the boundary line. Oops, sorry. Greater than. Perfect. So the overlapping shaded region is only between these 2 points, lines, sorry, and it doesn't include the red points. Perfect. Okay. So back to the slides. The students completed this exit ticket in class, so go ahead and take a few minutes to complete it on your own. So number 1 says which quadrant will be completely shaded in the graph of the inequality y less than or equal to 2x. Looking at the graph of y less than or equal to 2x, we can see that the first 3 quadrants are not shaded completely. Therefore, it must be that quadrant 4 is completely shaded by y less than or equal to 2x, as we can see in the picture. Number 2 says which ordered pair is not in the solution set of y greater than 2x plus 1. So these are our choices. Looking at the graph, we can see that all of the points are in the shaded region except 2, 5, which is on the dashed line. This is not a solution, since points on the dashed line do not satisfy the inequality. Therefore, our answer is choice D. There is another Desmos activity assigned for homework, which you should complete by class time tomorrow. The code for the activity is as shown. If you have any questions, you can email me. Have a good night.